Okay, here's a really great problem that's going to bridge our one-dimensional motion to our two-dimensional motion. And it's something that's not really clear in CATS, but if you pick up a couple of the other physics textbooks, either the OpenStax or you do have access to the Searway textbook in your WebAssign, but we've got a couple of different ones. So I've got two cows that are in the pasture, and this is just a simple displacement distance problem, except we're moving from one dimension to two dimensions. So I got a rancher down here, and she's standing at the gate, and because of reference points that she has in the gate, like the fence posts or a tree that she's had to mow around, she's got two cows out there, and they're standing in the pasture, and you all have to realize that my artistic ability is limited. She knows the distance between the individual cows. And she's wanting to kind of figure out why are all of her cows separated. And so she wants to know the distance between the two cows, even though she knows the distance to the one cow and to the second cow. So we can draw a diagram. And she's got this diagram, just like any good physics student is going to have. We're going to have a really good opportunity to draw diagrams. And so we've got a diagram there, and we know it's 5 meters to the first cow, and it's 7 meters to the second cow, and it's about a 42-degree angle between the cows. And what's the separation of the two cows? So again, we're moving from one dimension to the other dimension. Now, there's a couple of ways that you can approach this problem. One is we can use good old just geometry here, and I can do a right triangle, right? I can draw this line here, and I can do this line, and I've got a right triangle, and if I know that that's 42 degrees, I can do the complementary angle, and so then I have the hypotenuse and the angle, and I can find my adjacent side, and then I can find my opposite side, and now I've got that right triangle. And then I can go through here and do the same thing, get another right triangle there, and ultimately figure out what the distance is. So I can play with geometry and do it with geometry. But there's a simpler way, okay? A lot of things have a simpler way. So this one is, there are multiple ways of approaching it. We just talked about a geometric method, but here's another one that utilizes the law of cosines. So you may have run into this somewhere along the way. You may have seen it in trig, you may have seen it in a couple of other places, but I can take any triangle. Doesn't have to be a right triangle, doesn't have to be anything. I can take any triangle, and if I know two sides, I can figure out the other side. If I know two sides in an angle, I can figure out the other sides. And then I can also use the law of sine. So essentially, if I know two angles and a side, I can figure out the other side. Or so I can use these to really help me out. So the law of sines and the law of cosines really makes this problem very, very easy to attack. So now I'm going to come down here real quick, and we're going to go back to our cows. And so I'm going to draw my diagram again. We know that that's 5, that's 7, this is 43. I'm going to define that as A, define that as C, define that as B, do the calculations, and I find out that the A is 4.8 meters. We use the same technique to find distances between stars, distances between galaxies. So this really is a nice way to simplify a pretty complex problem where we could have been sitting back here with a whole bunch of geometry and taking forever to do it. Hopefully that will help, because we're going to introduce those two-dimensional concepts and work in two dimensions. And we've been working in one dimension, and now we're going to move forward. So knowing the law of cosines really is going to help us out.